Hi, today I want to discuss about molecularity, the number of reacting species, atoms, ions, or molecules taking part taking part in a elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Now, what is the meaning of this one? Mean number of reacting species that may be atom or ion or molecule that are involved in the elementary reaction. What is the elementary reaction? Elementary reaction meaning the reaction which occur in single step. The reaction which occur in single step, that is called elementary reaction, which must collide simultaneously in order to bring about a chemical reaction. It means this is a molecule 1, this is a molecule 2. These two are simultaneously collide and gives a product. So how many molecules collide together in a slow step or it is called single step? That is called molecularity of that reaction. So for example, here ammonium NH4NO2. This will be gives N2 plus 2H2O. For example, if it is an elementary step, then how many molecules are participated here? One molecule. Therefore, molecularity is equal to 1 for this reaction. Next, take another example. H2 plus I2 gives rise to 2HI. Molecularity for this reaction is equal to 2 because here hydrogen molecule and iodine molecule both are involved in this reaction if it is a elementary reaction. Next, another one example is 2NO plus O2 gives rise to 2NO2. Then here how many molecules are involved? Molecule number here 2 are there, here 1 are there. Therefore, molecularity is 2 plus 1 that equal to 3. Next, another example. So all these are which one? Elementary reaction. So in elementary reaction, how many molecules are participate? That is its molecularity. So number of species that are so in elementary reaction, number of species that are participating are called number of species that are participating are called that is molecularity. So like this I will give in general A gives rise to product. Then already we know its rate law we can written as K A power 1. Therefore its molecularity is M is equal to 1 and order also 1. Next A plus A, this gives a P. If it is all are elementary reaction condition, all these are elementary reaction condition. Then rate is equal to K, A concentration power 1 and 1. Otherwise you can write like this. This can be also written as R is equal to K, A power 2. Therefore, molecularity is equal to 2 and order is equal to 2. Next, A plus B that gives rise to product, then this can be written as R is equal to K, A concentration power 1, B concentration power 1. So therefore molecularity is equal to 2 and order also 2. Now next one, 2A plus B gives rise to product. Rate is equal to K, A concentration power 2, B concentration power 1. Therefore, molecularity is 3 and order also 3. Molecularity greater than 3 are rare. So, molecularity greater than 3 is rare. So you have to remember this. Molecularity generally, this is 1, 2, 3, but greater than 3 are rare. And it cannot be fractional and it cannot be negative, it not zero. So molecularity cannot be negative or fractional or zero. Always positive, that are 1, 2, 3 numbers. Now, KClO3, 6 FeSO4, 3 H2SO4, 2 KCl, 3 Fe2SO4 taken twice, 3 H2O. In this reaction, reactant is KClO3 and this FeSO4, H2SO4. Total, how many molecules are there? Here 1, here 6, here 3. Total 1 plus 6 plus 3 is equal total how many? 10. Already I told you that molecularity greater than 3 is very rare. Here molecularity appearing what is that? 10. It meaning this is not a elementary reaction, not a elementary reaction. This is complex reaction. Complex reaction meaning what is that? The reaction which occur in more than one step. Complex reaction. In this complex reaction, the reaction which occur in more than one step. So from this all discussion, from elementary reaction and complex reaction, order of reaction is an experimental quantity, but molecularity is we are determining from the reaction mechanism. In that reaction mechanism, some reactions are elementary reactions, some reactions are complex reaction. So order of reaction can be 0 and even fraction, but molecularity cannot be 0 or a non-integer. Now, second point, order is applicable to elementary as well as complex reaction. Now, whereas molecularity is applicable only for elementary reaction, because in elementary reaction, how many molecules are involved or atoms or ends are involved, that is called molecularity. Now, I shown one reaction, molecularity we got 10. So, more than 10 is rare. For complex reaction only possible there. Therefore, there is no meaning for complex reaction. Molecularity has no meaning for complex reaction. It has a meaning for only elementary reaction. Next, third one. For complex reaction, the order is given by the slowest step, and molecularity of the slowest step is the same as the order of the overall reaction. So in complex reaction, we have the more than one step, in that any one of the step is a slow step. So according to the slow step, we can determine the molecularity, because each step is a elementary step in the complex reaction. For example, I will give one reaction. In that, A2 is converted into A and A. This is one elementary reaction. Second one, B2 plus this A convert into AB plus B. Next, this A and this B both are convert. A plus B convert into AB. This is elementary reaction. This is, for example, fast reaction. This is a slow reaction. Again, this is a fast reaction. Now, this overall reaction is this A cancel, and next this A cancel, this B cancel. Then what is left here? A2 plus B2 gives rise to 2AB. This is 1AB, this is 1AB, 2AB. This is called overall reaction. In this overall reaction, which is a slow step, this is a slow step. This is called rate determining step. Rate determining step means the slow step which control the rate of reaction. The slow step which control the rate of reaction. That is called rate determining step. In this slow step, how many molecules are participated? B21, A1. Therefore, molecularity is equal to 2. Like this, we can determine molecularity from reaction mechanism. This is a theoretical process, not experimental process. Therefore, molecularity has no meaning for complex reaction. It has meaning for a elementary reaction, but order of reaction has a meaning for elementary as well as a complex reaction. So order of reaction is experimentally determined. That's why it can be any value, but molecularity is always 1, 2, 3. It cannot be fraction. Fraction molecule not there. A one molecule, two molecule, three molecule word will be there. Fraction molecule word not present. Therefore, molecularity cannot be negative and sorry, fractional. Negative mean molecule only not present. Zero mean molecule only not present here. That's why here negative and zero fractional not possible about the molecularity. This is one question. In that, first step is a slow step, that is called rate determining step. Second step is a faster step. From this step 1, step 2, we are getting the a overall reaction. From this, we have to determine the rate law. Generally, rate law is represented with respect to slow step. That is, you have to remember. Rate law is represented with respect to which one? Slow step. In that, what is the slow step? Rate is equal to K1. What are the reactant? Reactant is NO2 and O2. Sorry, NO2, NO2. Therefore, I can write NO2 concentration and NO2 concentration. This is equal to R is equal to K NO2 concentration power. How much here? 1 is it? So 1 plus 1, how much? 2. This is a rate law. Therefore, Now, molecularity is how many molecule participated here? 1, 1, 2. Therefore, molecularity 2. Next one, order. Order is what is the sum of the powers of the concentration terms of the reactant in the rate law. In this rate law, what is the power is there here? 2. Therefore, this is a 2. This is called order of reaction. This is molecularity. Now, always keep in mind rate law is represented with respect to rate determining step, that is called slow step. That may be generally first step, or that may be second step, or it may be any further step. So always how it is represented, it may be based on the first or second or any third, fourth, anyone, but rate law is represented always with respect to slow step. Here given the first one fast step, second one is a slow step, rate determining step, and next one is a fast step. Then here also we have to determine the rate law. What is that? Determine rate law. How to determine? Always based on the slow step. Which is a slow step? Second step. Then rate is equal to K2 N2O2 concentration and H2 concentration. Now this N2O2 is an intermediate. In rate law, intermediate should not appear. That is, keep in mind, in rate law, intermediate should not appear. Therefore, we have to remove this intermediate from the rate law. How to remove? By using the first step. So first step is the equilibrium. So at equilibrium, forward reaction rate is RF, that is called K1 NO concentration power 2. This is a forward reaction rate. Now R backward reaction, that and these are act as a reactant. Therefore, its constant is given K minus 1 and N2O2 concentration power 1. Now we want N2O2, therefore at equilibrium rate of forward is equal to rate of backward. So equation 1, equation 2, rate of forward, rate of backward is equal. Therefore I can write this is K1 NO square is equal to K minus 1 N2O2 concentration power 1. So now I want N2O2 means K1 NO square divided by K minus 1 is equal to N2O2 concentration power 1. Now this is equation number 3. So now we can put into the this one, first one. Then what is here? Rate is equal to K2 N2O2 plus we can write what in this one we can substitute with this one, that is called K1 NO concentration power 2 denominator K minus 1. Now next what is it? H2. Therefore H2. Now this is R is equal to all these together. I can write constant by constant, one constant, and constant into K2 another constant. Therefore overall I am writing this is a K. This is called overall rate constant. K is a overall rate constant, and this is NO square and H2. Therefore, in this reaction, slow step, how many molecules are participated? Now, this N2O2 and H2O2. Therefore, molecularity is equal to 2 because N2O2 and H2 participated. Order of reaction is 2 plus 1. Here how much is there? 2 is there. Here how much is there? 1 is there. Therefore 2 plus 1 n equal to how much? 3. This is called overall order of reaction. Overall order. With respect to NO second order, with respect to H2 first order. Like this, rate law will be determined. So finally, R is equal to KNO concentration per 2, H2 concentration per 1. This is a rate law for this reaction. So here given one overall reaction, this overall reaction, and they given here rate law also. So like this exactly matching or not, we can find out from this given mechanism. So first step is a fast step, second step is a rate determining step. From this 1 and 2 we are getting the overall reaction. So now always rate law we are determining from the slow step. Therefore, now I am writing here rate is equal to K2 and O3 concentration, O concentration. Now in this one, O3 is a reactant, O2 is a product. So O is not there in the overall reaction means this O is the intermediate. O intermediate should not appear in this rate law. So this can be removed from by using first equation. So at equilibrium, I am writing now, directly I am writing K1 O3 concentration is equal to K minus 1 O2 concentration, O concentration. Now we want only O, mean K1 O3 concentration divided by K minus 1 O2 concentration is equal to O concentration. Equation 1, equation 2. From equation 1 and 2, I will write R is equal to K2 O3. This O place I can write K1 by K1 minus 1 O3 concentration denominator O2 concentration. Now I am taking this constant and this constant. Constant into constant, R is equal to K is the overall rate constant and O3 and this O3 denominator is O2 concentration. Therefore, R is equal to K O3 concentration for 2 and O2 concentration denominator. This can be represented as R according to given question now. If you observe here, this given same pattern is there, but this can also written as R equal to K O3 concentration power 2 O2 concentration power minus 1. So order with respect to ozone is a second order, order with respect to oxygen is a minus 1 order. Now in this reaction, molecularity is in the slow step how many molecules are participated? Total 2. That is one oxygen, one is O3. Therefore, molecularity 2. But order of reaction is 2 plus minus 1. That is called 2 minus 1 is 1. Overall order is 1. But with respect to ozone, second order, with respect to oxygen is a minus 1 order. Now, here step 1, step 2 and overall reaction given. So which is the here slow step, that respective we can write the rate law. Now, rate law is R is equal to K. Here nothing given me, I can write K and H2O2 concentration and I minus concentration. H2O2 concentration and I minus concentration. This is called rate law because first step only the rate determining step. But you observe here overall reaction, what is it? 2H2O2 gives rise to 2H2O plus O2. In this reaction, anywhere iodine is not appearing, therefore iodine is which one? Catalyst. How to identify it is catalyst? Now, in this reaction, I minus initially used and finally we got as it is. Therefore, this is called catalyst. Initially, how much amount used, finally same amount formed and not appear in the which called the overall order. Therefore, that is called catalyst. So, in rate law, catalyst may appear, but intermediate should not appear. So, you have to remember in rate law, intermediate should not appear, catalyst may appear. That is important. Therefore, I minus is catalyst in this reaction. So whatever the faster step, next step is that is not helpful to determine the rate law because always rate law is determined from the slow step or rate determining step. Rate law. How to write the rate law? Always based on the slow step. Then rate is equal to K2 I minus concentration HOCl concentration. This is. But in this reaction, overall reaction, you can observe that here what is present? I minus OCl minus present. But HOCl is present or not? So in this one, HOCl is here formed. Then here this is utilized, mean this is intermediate. So that intermediate we have to remove. Now this can be directly, I am writing from the fast equilibrium reaction, that is called rate, that is forward is equal to backward. Therefore K1 OCl minus concentration H2O liquid. H2O pure liquid is generally not represented in the rate law. So that you want me, I will clearly write here because in the rate, what do you call that is? Equilibrium constant expression, that is rate of forward reaction that equal to um, OCl minus concentration and H2O concentration, but H2O pure liquid is not represented, therefore I am not writing this one because pure liquid doesn't affect the rate, therefore they are not represented. Next, rate of backward reaction is equal to, here K forgot, K1 is there, K1 and this is K minus 1 HOCl concentration and OH minus concentration. So now rate of forward is equal to rate of backward. Therefore, this can be represented as and K1 OCl minus concentration is equal to K1 minus K minus 1 HOCl concentration and OH minus concentration. We want K1 OCl minus concentration divided by OH, sorry, K1 K minus 1 OH minus concentration that equal to HOCl concentration. Now we can put into the first equation. What is that first equation? Rate is equal to K2 I minus concentration. Now in this HOCl place we can write here K1 OCl minus concentration divided by K minus 1 OH minus concentration. Now I can write this is R is equal to K2. Now this K2 and this all these are written as constant. This is called overall rate constant. I minus concentration OCl minus concentration divided by OH minus concentration. So rate law is equal to K I minus concentration OCl minus concentration OH minus concentration whole power minus 1. Here 1, here 1. Therefore, order of reaction molecularity is equal to in this one slow step how many molecule participated 2 molecule, therefore molecularity is 2. Order of reaction with respect to I minus is 1 plus with respect to OCl minus is 1 with respect to OH minus is minus 1. Therefore N is equal to 2 minus 1 that equal to 1. So overall order of reaction is a first order reaction. Like this you can determine rate law. From rate law you can determine molecularity, you can determine the rate. From rate law we can determine order of reaction. From mechanism we can determine the molecularity. That is very clear. Already I given one mechanism that is called A to convert into A plus A, B to A plus A convert into AB plus B, AB A plus B convert into AB. Overall reaction is A2 plus B2 gives rise to 2AB. This is the overall reaction. This is called first step. This is called K2. This is a K1. This is a K1 minus 1. This is a K3. Now this is a fast step. This is a slow step. Therefore, order of reaction or rate law can be determined based on rate is equal to based on slow step, that is called B2 concentration into A concentration. A is the intermediate that should be not appear in the rate law. Therefore, R is equal to for from the first reaction, forward reaction, what is it? K1 A2 concentration or backward is equal to what is that? K minus 1 A into A power 2. So forward reaction rate is equal to backward reaction rate. Therefore, K1 A2 concentration is equal to K minus 1 A concentration power 2. But we want which one? A concentration is equal to K1 into A2 concentration by K minus 1. Here square is the square removed, meaning this can be written as root. Therefore, this is also represented as A concentration is equal to K1 by K minus 1 whole power 1 by 2 into A2 concentration power 1 by 2. Separate I wrote. Now substitute in this equation. Then R is equal to B2 concentration and A concentration place we can write K1 K minus 1 whole power 1 by 2 A2 concentration power 1 by 2. Then R is equal to what is the all constant. Here I forgot what is it? K2 I forgot. Therefore here also K2. Then K2, and this all constant, overall rate constant, and this is called B2 concentration. This is called A2 concentration power 1 by 2. Therefore, overall rate law R is equal to K B2 concentration power 1 and A2 concentration power 1 by 2. Therefore, molecularity is in this step. This is B2 and A participated. Therefore, this is 2 and order of reaction is 1 plus 1 by 2. Therefore, N is equal to 3 by 2, that equal to 1.5 order reaction.